This is the Schrodinger equation. How is it derived? Well, that's why I clicked on this video. Let's see. So this is the Schrodinger equation, and we have to figure out how this is derived. So first off, I'm going to start off with energy equals kinetic energy plus potential energy. Pretty simple. So what we're going to do is we're going to say that potential energy is equals V. It's just an arbitrary variable. So E equals KE plus V. But kinetic energy equals half mv squared. So we can say that E equals 1/2 mv squared plus V. So what we're going to do is we're also going to rewrite this in terms of momentum. We'll see why later. So 1/2 mv squared in terms of momentum, because momentum is P equals mv, we can say that this is P squared over 2m. And if you expand P, we realize it's the same quantity. So we can say that E equals P squared over 2m plus V. Now, this is where it starts to get a little more complex. We have to bring in the wave function, psi. Psi equals e to the I kx minus omega t. And we see the second derivative here. So let's find the second derivative. So the change in psi over the change in x equals, we do the chain rule. So if we multiply this, we get ikx. So the derivative of ikx is just ik. So we do ik times the derivative of the outer function, which is itself, because it's the e to the x function. So we do ik e to the I kx minus omega t. Now we also see the second derivative, so we'll take the derivative again. We get d squared psi over dx squared equals, all we have to do is multiply the same thing again, because we can just factor this coefficient out. And we get I squared k squared. But I squared k squared, once we evaluate this derivative, is equal to negative k squared, because I squared is equal to -1. So we will write this as negative k squared e to the I kx minus omega t. So what we will do now is we will rewrite this e to the I kx minus omega t function as psi, because we know that's what psi equals. Therefore, d squared psi over dx squared equals negative k squared psi. That's what we know. So what we will do now is I will introduce a relation called the de Broglie relation. So this means that k equals momentum over h bar, where Planck's constant, it's just Planck's constant over 2 pi. That's basically all it is. So let's make the substitution. We can say that d squared psi over dx squared equals, well, k equals that, so it's negative p squared over h bar squared psi. Now what we're going to do is going to multiply both sides by negative h bar squared. So negative h bar squared d squared psi over dx squared equals p squared psi. So what we're actually going to do, given this, we're going to actually multiply every single term in this equation by psi, and you'll see where that takes us. We get e psi equals, now we have to multiply everything by psi, so we get p squared psi over 2m plus v psi. But since we know here, p squared psi is actually this entire quantity, so we can rewrite this as e psi equals that whole quantity, which is negative h bar squared d squared psi over dx squared plus v psi. And now let's check if that is the same Schrodinger equation. Yes, that is. Now that is the derivation of the Schrodinger equation.